So yesterday we mentioned this towards the end of our last lesson. If you want to differentiate x to power n, it's like bringing the power back to the coefficient, then subtracting 1 unless 1. If you want to differentiate the product of a function of x and a constant, which means a term with coefficient, sort of, you can ignore the coefficient at first, differentiate the function, then multiply. So basically you write it as the constant times, then you differentiate, because you have to carry the coefficient along every step of the derivative as well. If you differentiate a constant, it's always 0. And if you differentiate a polynomial, you differentiate term by term by observing the basic rules. So these are simple rules or techniques of differentiation. They are the basis of other so-called complex rules, some of which we will begin by Monday. So we're just going to take a few examples. If you have your textbook, fine. If you don't have your textbook, no problem. Let me go to the exercises. So we just start from there immediately. All right. I'm sure some of us must have done a bit of this during IGCSE days. If not, no problem. Okay, can you see the book now? All right. So I believe this is easy. Can you try on your own? So I do not just spin feed you every time. So I want you to try 1A, 1B. So I'm going to take 2. 1A, 1B, 1E, 1F. Then the last 2 polynomials. So A, B, E, F, S, T. A, B, E, F, S, T. That's from page 438. Question 1A, B, F, S, and T. That's exercise 17A. So I put it on WeChat if you are wondering what questions to do. Let me see your presentation, especially. Well, an example is here if you need to, but I want you to try without looking at that, just by using the rules of differentiation, okay? Then we can now do it together. I'll send this to the group. Should anyone wish to do more practice later on their own, since I do not expect everyone to have their book with them. Sorry. Send to WeChat if you need the questions. A, B, E, F, S, T. It's okay to make mistakes, just attempt. So I'll pause the recording since there's no point to record now. If the question says find f dash of x, make sure you write your answer as f dash of x is equal to something. If the question says find dy by dx, present your answer as dy by dx is equal to something, okay? But we know it's the same thing. It's just like somebody speaks English to you, you reply them in English. Somebody speaks Chinese to you, you reply them in Chinese, even if what you're saying is the same, okay? Just for consistency or whatever, I don't know what to call that. Checking Krista K now. Are you sure you are doing what I asked you to do, Crystal? You are still using the first principle. No, we are now using the techniques of differentiation, Crystal, not the first principle. Okay.
I didn't.
You didn't read the instruction.
No, I didn't erase it.
You are showing off your skill. Now we know you're smart, okay? Stop showing off your skill. Anyway, it's good. I've seen that the rest were done using the rules, yeah? So one thing about the examination is if the question doesn't say differentiate using the first principle, you're supposed to use the rules of differentiation. Okay? If the question wants you to use first principle, it will be stated differentiate by using the first principle. That is when you use that one. Okay? Because the first principle has been able to summarize a formula for us, and those are the simple rules of differentiation. So there's no point going back to the beginning when there's a summary already. Okay? This is good. 0 minus 1. Yeah, derivative of x is always 1. I hope everybody knows that by now. Derivative of x with respect to x is 1. Look at it. It's a straight line, isn't it? It's a straight line. The gradient of that straight line is always 1. And that's what derivative is all about, right? Good job, Krista. I've checked what you sent in. Okay, I've seen the S part now. Well done. So number 2, good. Yeah, you have to first of all put it in that form, yes. Nice. It's easier than I thought for you guys. Good job. You see, even without giving any example, you just look at the rules, you follow the rules, and it's good. Miss V, I still see the nx, n minus 1. Are you like thinking out loud or just trying to state the reason? There's no need to state all that. For this aspect, okay? It's not a proof, we are simplifying. Do you understand? Okay. So there's no need to put all those formula or reason. I understand you want to explain, like I always tell you, that you have to tell us why. But for this, we don't require it. It's just like solving an equation with a fraction, and you're explaining to us why you cross multiply. Like, you understand what I mean? But if you're trying to prove something, especially something complicated, like the proof we did in class, we have to say, oh, because it is continuous at this point, oh, because it is differentiable. So then you can be more detailed. But here, by stating your f and you put it in the right form, the next thing should just be f prime of x, and you write the answer if you can write directly. I need you to check your t. Minus 2. 2 is a constant. If you differentiate that term, you should get a 0, isn't it? Benna? Understand? Yeah, so check that. Then that's then you should check number S as well. Same thing applies to 7, yeah? Every other thing looks good. Mr. Chang, I'm checking your work now. Yeah, looks good up to T. Checking what you just sent in now. Okay, so if you look at number 2, Ethan, it wasn't given in negative power, right?
Can you say that again?
Number 2A, it wasn't given as negative power of x. You wrote that.
Yeah.
So next time, I want you to start with the format that was given. Okay, it's equal to that. Okay, you can write it on the same line, just 3 things. F of x equals 1 over x squared, which is equal to x to the power minus 2, which implies this. Then make sure your answer is back to the format that was given. The format that was given has no negative power, so you have to change it back. Okay?
Okay.
So apart from that, I think your work looks perfect. Your work looks good. Yeah. Callista, checking your latest submission. Whoa, a lot of work now. Good job. Nice, 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 and nice. All correct, Callista. Okay, checking. Karen. So in your solution, you wrote ax cubed. You can actually just write a f of x is equal to x cubed, because that's what the question is trying to tell you.
Wait, sorry, where are you?
I'm in question 1. Your solution of all question 1. The question says, given that f of x is, so there's a preamble for all the questions already. You are not the one assuming it is f of x. It's already given. So all the first line you wrote were not necessary. So you can actually reduce the space used. Okay? So you don't have to erase anything. Just to you can just cross it or take note, whatever. But because it's already stated as
so I don't need the so I don't need the line f of x equals.
No, you need that line. You don't need the first line of copying exactly the way it is.
All the question. Okay.
Just the way you present it. Everything else I think is okay. Double checking. Okay, look at 1s, Karen. You don't need to rearrange.
Oh, okay.
Okay, so it's okay to add -1 minus 12x squared. It's fine. The only case where you may arrange a polynomial, especially, is 1, when given the instruction to arrange it in maybe ascending order of x or ascending powers of x or descending powers of x. Okay? Just like when we did a binomial expansion, the question would be specific to leave it in ascending or descending powers of x. Okay? So that's one case.
Okay, yeah.
Another case is, oh, she can hardly hear me, I think.
Yeah, I can barely hear you.
Uh-oh. Is everybody experiencing the same thing, or is it just Karen? Raise your hand if you heard me loud and clear. Uh-oh. Karen, maybe you can check your device.
I think I turned it to the loudest already.
Uh-oh. But I can hear you loud and clear.
I don't know why.
All right. I hope internet doesn't misbehave like last time. I think it's your internet. Okay. So my point, so you understand the first condition, right?
Yes.
So the second reason where you need to rearrange is if the term containing the highest power of x is positive, but the others are negative, or the other way around, then you can take the positive first. Otherwise, you don't need to rearrange any polynomial.
Okay.
All right. Well done.
Thank you.
All right. Let's look at the next submission. Lily. Technically, shouldn't use it. No. Don't use quotient rule, Lillian. We are not there yet. Okay. You can, split into 2 fractions or more fractions.
Yeah, I didn't use.
You didn't use. Oh, okay. Oh, you're trying to justify what you did. I see what you mean now.
No, I mean, like, if you have to simplify the fraction, then you're dividing by 0, right? I mean, you might be dividing by 0, right?
What do you mean?
Like, if you split it into 2, and then you get, like, x cubed divided by x, you just write x squared. Just write.
Oh, I didn't get what. Okay. Wait. Which question are you referring to?
2o.
2o. Okay, let's go to 2o. So you split it, you have x squared and you have 4 over x. What I will expect you to write next time in front of that x squared plus 4 over x is x squared plus 4x minus 1.
Square what?
2o, right?
Yeah.
Did you see the line x squared plus 4 over x? I hope I'm looking at your solution. Yes, I am.
What? 2o is
I'm talking about your second to the last step in your solution already.
Yeah.
X squared plus 4 over x. Can you see that?
Yeah.
So the next thing I expect after that is x squared plus 4x raised to the power minus 1.
Oh. No,
Okay.
I mean like if it says x cubed over x, we can just simplify it, right?
Yeah, definitely. You have to simplify. That's what you have done is fine. But I need you to show me x squared plus 4x to the power minus 1 right after that. You can write is equal to on the same line. Okay? And when you differentiate, your derivative, I want to see that negative 4x raised to the power minus 2 first before you write this. Understand?
Okay.
Okay. Then same with any other similar work. So it says, since we are just simplifying, how do we know if and when we are dividing x is not 0? Oh, we don't know. So basically, the function if that function exists, it means x cannot be 0. We're only differentiating a function that exists. Differentiate means, oh, we want to find the differential coefficient or the gradient function. It means it exists at that point. And if we need to rule out 0, then it will be stated earlier. You don't need to bother about that. We are only simplifying, so you can go ahead and simplify. It doesn't affect it. Okay? All right. Clarissa, good. Check your work. Nakita, checking. Yeah, looks good. So Nakita, for O, where is she? Let me go to you. Yeah, I'm trying to. Okay, there you are. So for that 2O, the best thing is to split into two fractions first. So you have something like x cubed divided by x plus 4 divided by x.
Okay.
Okay, so you don't need to go that route. So you can write or and write the other one just beside it. You're still going to end up with x squared plus 4x minus 1 like you wrote here clearly. Makes sense. And the last one, yeah, you did that in the last part. You split. Okay, good. So because it was a single fraction, Nakita, from the beginning, your derivative could also be combined later.
Okay.
Okay? But if you don't combine it, I'm sure it will be welcome.
Okay.
Ethan, I'm checking your work now. Nice. Okay, so you skip a lot of stuff. I did before. Okay, nice. Okay, so you fix that henceforth. You have to show me those details. Okay. Clary, checking the last part that you sent in. So Clarissa, you can take it back to positive powers of x. The J question, 3 plus x to the power minus 2. So you can write one more step, 3 plus 1 over x squared, the minus 4 divided by x cubed.
Okay.
Okay, just to be, like the question that was given. Same with the cave question, but this makes sense. I'm checking your question 3 now. First, use laws of indices. Perfect. Nice. Laws of indices. Nice. You split again. Nice. Wait, how do you get x root x, Nakita? Just write it as
Which
1
one?
over.
Which one?
I'm talking about the last question, J.
Oh, okay.
So you have minus 1 over 2x minus 3 over 2, right? Then
Mm-hmm.
that was going to become plus 4x minus 2. So the second part is okay, 4 over x squared. So this is, how do you get the 2x root x? So probably you could just also put minus 1 over 2, then that is square root of x cubed, right?
Yeah.
So if you can just write square root of x cubed first before you write this, I think it will make a lot of difference. Or you could just leave it as 1 over 2, blah, blah, blah. But if you could write just one more step, I think it's fine. So what your final answer is okay. Just one more step would be nice.
Okay.
Okay, Calista, we need to work on the presentation here. Where are you? Let's talk about number 2. So number 2, you wrote 1 over x squared equals, okay, I come to the board so you can understand the issue I have with this presentation. Can you see my board?
Yes.
Okay. So you have, I'm going to write what you sent to me first. So you have something like 2a 1 over x squared. Sorry, I'm not sitting properly, so my hand is not balanced the way I'm sitting. You had that, and then the next line, I saw this is equal to right? So, few problems. Number 1, and I want, anyway, you are the only one that have committed the blunder so far, so maybe others can pay attention to this. Question, the first problem I have is, are you calling this f of x or are you calling it y? We don't know. So I will expect that the first line you write y equals that, which is that. Then here, this is where your dy dx begins. It begins from here, the derivative. So what you have written, you made it look like this 1 over x eventually becomes this. Is that true? So that's how you make it look like it's equal to, so this is equal to this, which is equal to this, which is equal to this, which is equal to this. That's what you have done. Even though I understand what you're trying to do. Okay? So what you should do is that, then this is where your derivative begins. dy dx is equal to, then you write what you have written. Okay? And if you don't call it that, you can start from the beginning and just say f of x equal, because it wasn't given anything in the question. It wasn't given f of x in the question. So you can call it f of x, which is this. So instead of dy dx, you can say f dash of x equals that, then you continue. Last but not the least observation, how you subtracted minus 1 is not a compulsory step. If you are putting that to avoid any mistakes, it's fine. But you can jump from dy dx, you can just write dy dx is equal to this, is allowed. Then you show how we converted it to this. Understand? Yes? Yes or yes? Understand? Yes or yes? Yes. Okay.
Yeah.
All right. So that's a major blunder. You need to really take note. Another thing I noticed, Callista, is question 2J. You wrote 3 brackets 1 x raised to power 0. There's no need. Derivative of x is 1. Just write 3 brackets 1. Let me show you if you are wondering why derivative of x is 1. I'm not saying you are, but just in case you are wondering. If y is f of x, if y is x, are you focusing on my correction, man?
Mm-hmm.
Remember, if you have y equals x to power n, dy by dx is nx n minus 1. So in this case, our dy by dx is 1x 1 minus 1. So it's like a rule. Okay, you don't need to show all this. And I said it a moment ago that this line, this y equals to 1 is this, and the gradient is 1. That's exactly the meaning of the results, that this gradient is 1. So when you are doing something, maybe I give you a problem like y is equal to x squared minus x plus 7. dy by dx is 2x. I don't have to say 2 minus 1. I can write the new power as that. Then I just need to say minus 1 if I wish plus 0. So you don't need to show all the basic details behind it. That's my point. Okay? All right. Good luck. So you can adjust what you have now. Okay? Let's see who's next. Yeah. Check your work, Brenna. That's good. Yeah. You think I've checked 3A correct. Checking 3B now. Correct. 3J. You split. So Ethan, if you look at 3J, 1 over 2 root x cubed. Remember, your x cubed is x squared times x, right?
Wait, can you say that again?
Look at the board. 1 over 2 root x cubed. You kind of put your cube on that. So I need to know, is your cube covering this, or is the cube right inside? So both of them are correct, but you need to, stick to one, not in the middle. Okay, so I assume this is what you mean. If this is what you mean, so I'm trying to use Nakita's idea earlier. Do you agree? This is what happens, right? So you are okay to write your answer as 2x root x if you want, or you just leave it as this. This is not compulsory. You can leave it as this, but you need to tell us, what are you trying to do? Are you writing 2 brackets that, or are you saying, because according to the law of indices, this 2 means x to power 3 over 2, okay? But don't put it in the boundary. We don't know. Is it in or out? Okay?
Okay.
Yeah. So I just want us to practice a few more. There's not much to be done today. Everything I can see you're doing great so far. So who is this? Krista C. I think what I told Colista applies to you as well. Where's Krista C?
Yes.
So you wrote one of our, were you listening when I was talking to Colista?
Not really.
Uh-oh. So please look at the board.
Mm-hmm.
Can you see this?
Oh, you mean the formula? Like.
There should be the difference between this and they are different things. But the way you presented it is like this is the same as the second line, the same as the third line. No, the first line is not the same as the second line. This is the function. This is the gradient function. Are you getting my point? This is the function, whether you call it f of x or you call it y. So I've written how it should be done in two ways. The first way is this. Is either you call it y so that you can call the result dy dx, or you call it f of x so you can call the result f dash of x. So if you write dy dx once, you can now use is equal to connect them. But the first line is your y. It's not the same as the second line. Okay? So you need to label your work properly. I think that is one major error that I've seen in your question 2. So your first line is your y or f of x. The second line is where your derivative begins and your simplification makes sense. So I'm going to check O and P. Okay, if you don't mind, guys, let's do O and P together for number 2. For those that have not done it, anyway, if you have done it and I've given you feedback, you don't need to waste time listening to me. You can proceed with what you're doing. Can somebody, Krista, please, Krista C, give me question 2O, so I do not go to different windows.
X cubed minus 3
Say that
divided
again?
by x cubed minus 3 divided by x.
Like that?
Yeah.
So that's the question given. So the first thing I need to do is to call it y. You can call it f of x. Okay? So here, then I will say y is equal to x squared, x cubed divided by x, 3 divided by x. So which means my y is x squared, 3x minus 1. Because the rule says it's talking about x to the power n. So I need to make sure everything is in that form. Understand? So dy by dx, because I call it y, will be, the first will be 2x, then the second will be negative 3, negative 1, negative 2. I hope that makes sense. Yes?
Mr. Daniel,
Yeah?
I think 2a or 2o is x cubed plus 4 divided by x.
Krista, you didn't get enough sleep. Krista C, maybe you didn't get enough sleep. Okay, so let's, like that, let's just change that. So this is 4, this is 4. Is it okay now?
It's plus 4.
Yeah. Like that? Yes? Talk to me, please.
Yes.
All right. So with this now, I have 2x minus 4x to the power minus 2. So I can rewrite it back the way it was before. I can stop here, or I can merge it as a single fraction because the question was a single fraction. Something like that. Those of you that have done it, please confirm if this is what you got. All right. So for 2p, what does 2p say? 2x minus 5 over x squared, yes? Okay, instead of 2p, maybe we take something in question 3. I'll take 3p instead. 3p. Please listen to me. So 3p says, so I call it f of x this time. F of x equals x squared minus x plus 2 everything over cube root of x, right? So this can now be further simplified as x squared divided by square root of x means x to the power 1 over 3. X divided by x to the power 1 over 3 plus 2x to the power 1 over 3. I hope you're listening. Okay, so I'm still dealing with my function. I have not started the differential coefficient or the gradient function of f. So this will be x2 minus 1/3. This is x1 minus 1/3. And this is just 2x 1/3. So I can write one more step. 2 minus 1/3 is what? Is that 4 over 3? That's 1 2/3, 5 over 3. Confirm, please. Okay, 5 over 3. This is 2 over 3. And this remains what it is. Yes? Okay, so now we can differentiate. So the function ends there. Now the derivative begins. So because I call it f of x, my derivative will be f dash of x. Then that will be 5 over 3 x 5 over 3 minus 1. Because this is a fraction, it's okay to write minus 1 and show me. If you don't show me also, no problem. If it's a whole number, you don't need to show me it's minus 1. Understand? That's trivia. X 2/3 minus 1. And this is 2 times 1 over 3 x 1 over 3 minus 1. Is that okay? So we simplify, we get 5 over 3 x 2 over 3, 2 over 3 x negative 1 over 3, then 2 over 3 again, x negative 2 over 3. Is that correct? Hope you guys are checking what I'm doing and following so I do not write something wrong and it takes forever for us to figure out where the mistake is. So the first one doesn't look like it's a problem. The first one is okay because it's positive power. The second is a negative power and I do not want it to be a negative power, so I can take it down. Can you see? Something like that. And here I can have 2, 3x 2/3. So it's okay to leave it this way, even with fractional power. You don't have to take it back to third. Okay? But if I want to write it in form of a root, so this is simply the cube root of, right, x squared. But you need to be careful how you write cube root. So it's not read as 53. That's why I use the bracket. Hello, understand? Karen? If I do not put the bracket, I don't want it to be seen as 53.
Then how about the 5 over 3?
I'm going to write the 5 over 3. I'm just saying like this cube root. Okay, so it's safer to just put a bracket. Then there's over 3. Okay, and this is 2, then 3. Again, there's a cube root. I don't want it to be seen as something else. Then this is 2. There's another cube root. So this is just more complicated stuff. So it's okay to leave it here. Talk to me, understand? All right. Where's Karen? She disappeared. I think our network is having an issue. Anyway, these are basic stuff.
Yes.
Karen, did you hear me? Okay, all right, just checking. So these are basic stuff. I will let you go in about 5 minutes. But before I let you go, let me, where is is it? Okay. Let me see. Okay, let's play some examples, all right? So that whatever I forgot to mention can be mentioned in the example. So please, I want everyone to listen to the example. So I'm going to play the example from example 1. And after that, we can close the class. Please tell me if you can hear the audio. Just give me a thumbs up like that once I play it. Please, I want everybody to listen. I know the first one is obvious, but as trivial as it is, let's listen, okay? Thank you.
There are rules we can use to differentiate functions without having to use the method of first principles. Look at the function to be differentiated in part A. It contains several terms added together. We can differentiate this function term by term. Notice that each term involves a constant multiplied by a power of x. To differentiate these terms, we can write the constant in front and then differentiate the power of x. So, to differentiate 5x cubed, we first write the 5 in front. Now, the derivative of x to the n is n times x to the n minus 1. So, the derivative of x cubed is 3x squared. To differentiate 6x squared, we write the constant 6 in front, and the derivative of x squared is 2x to the 1, or 2x. Notice how the power of x decreases by 1. To differentiate minus 3x, we write the constant minus 3 in front, and the derivative of x to the power 1 is 1 times x to the 0, which is just 1. The derivative of the constant term 2 is 0, and so it is not included in our calculation. We then expand the brackets to find the derivative. In part B, we notice that the last two terms are not written in the form of a constant multiplied by a power of x. We use the laws of exponents to write the terms in this form. To differentiate 7x to the 1, we write the 7 in front, and the derivative of x is 1 times x to the 0. To differentiate minus 4x to the minus 1, we write the minus 4 in front, and the derivative of x to the minus 1 is minus 1 times x to the minus 2. To differentiate 3x to the minus 3, we write the 3 in front, and the derivative of x to the minus 3 is minus 3 times x to the minus 4. We expand the brackets, then remove the negative exponents by writing the terms as fractions. Look back at the terms you have differentiated. With practice, you should be able to make the differentiation process quicker by immediately multiplying the constant coefficient by the power and subtracting 1 from the power. This should allow you to skip the first step of the differentiation.
Okay, so that's 1. So is the next one. Give me a thumbs up if you hear the audio. And it starts now.
The rule for differentiating powers of x also applies to fractional powers of x. Look at the function to be differentiated in part A. We use the laws of exponents to write the terms in the form of a constant multiplied by a power of x. For each term, we can apply the rule for the derivative of x to the n. To differentiate 3x to a half, we write the 3 in front. Then we have the power 1/2 times x to the minus 1/2. To differentiate 2x to the minus 1, we write the 2 in front. Then we have the power minus 1 times x to the minus 2. We expand the brackets, then remove the negative exponents by writing the terms as fractions. In part B, we start by writing the second term as a constant multiplied by a power of x. The derivative of x squared is 2x. To find the derivative of minus 4 times x to the minus a half, we write the minus 4 in front. Then we have minus a half times x to the minus 3 over 2. We expand the brackets, then remove the negative exponents by writing the terms as fractions. With practice, you should be able to make the differentiation process quicker by immediately multiplying the constant coefficient by the power and subtracting 1 from the power. This should allow you to skip the first step of the differentiation.
I think it's the audio is faster than what you are seeing, right? Anyway, so this is what I said earlier. You can go up to this point, or you could just leave it as x to power 3 over 2. Okay, that's also allowed. The third one quickly. Is this the third or the fourth? Oopsie. Find the gradients. Okay, sorry. Yeah, that's the third one. Can you see find the gradient of tangent at something, something? Okay, this is the third one.
Finding the derivative of a function allows us to calculate the gradient of the tangent to the function at a particular point. We first use the laws of exponents to write the second term as a constant multiplied by a power of x. Notice that the function is given in the form y equals something, so our derivative function is written as dy by dx.
Did you hear that?
The derivative of x squared is 2x. For the next term, we write minus 4 in front, and then differentiate x to the minus 1. We expand the brackets, then remove the negative exponents by writing the terms as fractions. This derivative function tells us the gradient of the tangent to the curve for any value of x. We substitute x equals 2 into the derivative function to find the gradient of the tangent at this particular point. The result is 5. So, at the point where x equals 2, the tangent to the curve has gradient 5.
Does that make sense? So last but not the least, so I let you go so I can get out of your life for today. I'll come back to your life on Monday, apparently. So the last but not the least is this, not this one. Can you see? So interpreting, because all these are type of questions you will meet in all the questions I sent to you and even the worksheet I gave you in school.
It is important that we can not only find a derivative function, but also that we understand what the derivative means. The function we are given here is simpler than the previous examples. This gives us the opportunity to skip a step when we differentiate it. We still find the derivative term by term. The derivative of 3x squared is 3 times 2x, which is 6x. We can perform this in a single step by multiplying the constant by the power of x, then subtracting 1 from the power. The derivative of minus 4x is minus 4 times 1x to the 0, which is just minus 4. Having found the derivative function, we can interpret it in 2 ways. dy by dx is a gradient function, which can be used to find the gradient of the tangent to the curve at any point. It also tells us the instantaneous rate of change in y as x changes, which is useful when solving real-world problems.
Can you hear that? So that's the interpretation. It is because in the previous example, a particular value of x was given, right? That is the instantaneous rate of change at that point. Remember, we talked about 3 rates of change. Can somebody remind me one without looking at your book? Talk about 3 rates of change. Give me one quickly.
Continuous.
Say that again.
Constant.
Continuous.
Continuous? No, that has nothing to do with
Wait,
it.
wait, no.
Constant.
Nakita, you said?
Constant.
Constant, yes.
Average.
Average. And the last is instantaneous. Okay? Mr. Chang didn't get enough sleep. So the constant one is when you have a real life problem whose model is a straight line. Okay? The average is when you have a real life problem which gives a curve. So to find an average, you will say, okay, for the entire journey, the average speed is, you find the speed at 2 different points, you add it together, you divide it by 2, then you said you have found average, sort of. So basically, we are drawing a tangent to that curve to find the gradient within those 2 points. Sorry, a chord to the curve, a chord to the curve, okay? And you make use of those 2 points of intersection of the chord, then you find the gradient. I hope everybody understands, remembers what I'm saying. Then the last but not the least is the instantaneous rate of change. Karen is gone. Instantaneous rate of change. It means we can find the rate of change at that instant. And one major real life example for that is when you're driving a car and you look at your speedometer and it says 5 kilometers per hour, even though nobody drives like that. And it says 5 kilometers per hour. That is your speed at that instant. Okay, you can look at it while on the speed and it says 60 kilometers per hour the next 5 minutes. That is the speed at that instant. That is the instantaneous. So if there's a curve, for example, and it goes and it goes and it goes, if you find a gradient at a point, it might give you 5. You find a gradient at another point, it might give you 60, because the curve slopes differently at different parts. Okay, so the gradient of tangent to a curve is actually the instantaneous rate of change. And that is the dy by dx you will always come across as we go on. Okay, so that is why when that question was differentiated and interpretation was required, it simply means 2 things. Oh, for this function, the gradient function for this function is 6x minus 4. It means if I'm looking for the gradient for any x, I can use the function 6x minus 4. That's why we call it a gradient function. It's a function on its own. If this is y, we could call this g. If this is x, f, we could call this g. Okay, it's also a function on its own. That's why we call it a gradient function. For a straight line, there is no gradient function. For a straight line, you're going to end up getting a number. So we don't have a gradient function for that. Well, we can call it a function also. That would be a constant function, if you get what I mean. Okay, so another way to say it is that, oh, this function, this 6x minus 4 represent the instantaneous rate of change of y with respect to x. So I've sent in some applications in maybe profits and whatever. So please make an attempt to interpret it, and we can also share ideas when we come next time. Either on Monday or maybe when we meet in school in person, you can share ideas with your friend. Feel free to send messages to people on WeChat. Do not stop learning, whatever you do. Okay, everyone? So we will stop here today. I will send the video. Oh, I got a message. Yeah, that's from Miss Coffee. Yeah, I know it. See you guys on Monday. Karen, did you hear the last part? I think your internet has issue. She looks like she's here, but I don't think she's here. The screen is frozen. That looks funny though. It's like, okay, I'm taking a picture. What is that challenge they do? Like everybody freezes.
Yes.
What is that challenge? Do you remember what I mean? There's this popular challenge on the internet, like everybody will freeze, a song is going on. I think Karen is doing that to us all the time. No, I don't think so, Ethan. Black Beatles? No. There's a challenge. Come on, you guys know much about all this Snapchat and Instagram than I do.
That should
But
be
you
the
know,
song.
no, I'm not talking about the song. I'm talking about the name of, yeah, the manicure challenge. Yeah, I think Karen is doing that all the time. Karen's internet is doing that to Karen. She just freezes. All right, I'll see you guys on Monday. Enjoy your weekend. Bye.